Welcome back to my YouTube channel. In our last video, we started chain rule and we were able to solve some questions on chain rule. And in that last video, we said I said I was going to solve this guy. I gave it, I said drop your answer in the comment section. So if you were not able to get cosec x, how to use chain rule to get it, I said I was going to solve it in the next video. So we'll do it in this video and solve 2 extra questions. And that will be all for chain rule. So before I continue, please do not forget to like, share, and subscribe to my YouTube channel. Let's dive into the first question. All right, the first question, we want to differentiate cosec x. So let me assume that y is equals to cosec x, and we are looking for dy over dx. So we're looking for dy over dx, given that y is equals to cosec x. So basically, the first thing we have to do is we have to realize that cosec x is the same thing as 1 over sine x, right? Then the next thing is to bring sine x up. So if I bring it up, this is like sine x raised to power 1. So if I bring it up, this will be sine x raised to power minus 1. So according to chain rule, we'll bring down this power, subtract 1 from it, then differentiate what was inside. So our dy over dx will bring down this power, which is minus 1, subtract 1 from it. The reason why I'm giving space is because I will differentiate this guy, subtract 1 from it, then differentiate this guy. If I differentiate sine x, I'll get cos x. So please, if you don't know how I got that, look at the table. If you differentiate sine x, you get cos x. This table, you're supposed to know it by heart. So this becomes minus cos x sine x raised to power minus 2. If I bring this guy down, because in indices we don't want a negative power, the power will be positive. So this is sine x all squared. Now this answer is correct, but we want to simplify it further. So our dy over dx will be minus cos x all over. If I square this guy, this is the same thing as sine x times another sine x. That's what gives us sine x squared. So what is cos over sine? Now we know that tan x is the same thing as sin x. If you don't know this, please take note. I'll be doing a video on trigonometry and we'll also prove this. Tan x is always sin x over cos x. And we also know that cot x is 1 over tan x. So that simply means cot x will be the reverse of this guy. So cos x will go up, sin x will come down. So that will be cot x. So it means that cos x over sine x is actually, don't forget this minus sign, is actually cot x. Then secondly, this is 1 over sine x. Now what is 1 over sine x? Remember that we said 1 over sine x is same thing as cosec x. Why 1 over cos x will be the same thing as sec x. So this is our final answer, dy over dx, which is exactly the same, minus cot x cosec x, which is the same thing as this, minus cot x cosec x. So that's all for the first question. Let's move over to the second question. The second question, we are asked to differentiate this 1 over 2x squared plus sine x raised to power 4. Okay, 2x squared plus sine x, everything raised to power 4. So let me assume that this is y. So to find dy dx, this guy will come up. So this becomes 2x squared plus sine x, everything raised to power minus 4, because we are taking it up, it becomes minus 4. So according to chain rule, what we are supposed to do is this power will come down, which is minus 4, times, we'll subtract 1 from the power as well. We'll subtract 1 from the power. When we subtract 1 from the power, we have this guy. Then we differentiate this inside function. If I differentiate 2x squared, you get 4x. If I differentiate sine x, I'll get cos x. Please, if you don't know how I got 4x, power will come down to meet this. That's 4. Subtract 1 from the power. Also, do it to watch the first video. I explained how to do that. Then if you differentiate sine x, you get cos x. So that's how I arrived here. So this becomes minus 4x plus cos x. Then in indices, I don't want negative power. This guy is the same thing as minus 5. So I'll bring it down so that the power becomes positive. So I have 2x squared plus sine x raised to power plus 5. And that will be the answer. So let's do the last question. The last question, let me try and use this space. Let me try and use this space. So the last question has chain rule inside another chain rule. That, as a matter of fact, that's the reason for a part 2. So that you see that you can have chain rule inside chain rule. So this is the last question. Cube root of this guy. Cube root of exponential x plus sine cube x. Sine cube x. So let me assume that y is equals to this. So we can rearrange this. Cube root simply means raised to power 1 over 3. Please watch the first video if you don't know how I arrived at this. So this is raised to power 1 over 3. So according to the rule, our dy over dx will be this. We'll bring down this power, which is 1 over 3. Then subtract 1 from the power. I'm giving this space because I must finally differentiate this inside. Subtract 1 from that power. If I subtract 1 from the power, I will get 1 over 3 minus 1, which is the same thing as 1 minus 3 all over 3, which is the same thing as minus 2 over 3. So this whole guy is the same thing as minus 2 over 3. So let me just wipe it. This becomes minus 2 over 3. All right, so the last thing is to differentiate this inside function. If I differentiate exponential x, I'll get exponential x back. But then if I want to differentiate sine cube x, I will have to apply another chain rule because sine cube x is the same thing as sine x raised to power 3. So to apply chain rule, power will come down, which is 3. Subtract 1 from the power, which is sine x raised to power 3 minus 1, which is same thing as sine square x. Then finally differentiate this inside function. So let me quickly do that. So this guy will have sine square x. Then finally we'll differentiate this inside function, which is cos x. So that's it. Close this bracket. So this is it. Then if I bring this power down, I will have 1 over 3. The only thing that will be top, because this 3 is down, the only thing that will be at the top will be this guy that we got. So don't forget, how did we get this answer? We differentiated sine cube x. Power will come down, subtract 1 from it. Then differentiate the inside function, which is sine x, you will get cos x. Then this guys will come down to meet 3 because of this negative power. So we have this raised to power 2 over 3. What does over 3 means? It means cube root. It means cube root. Then we have square. And that will be the final answer for this question. So before I end this video, I would like to give you the standard formula for chain rule in this context. For chain rule, this will be the standard formula for chain rule. Let's just quickly derive it. We have a certain function y is equals to u raised to power a certain n, where u is a function of x. Take note, u is a function of x. So what will be our dy over dx? We know that dy over du, if we are differentiating y with respect to u, power will come down and we subtract 1 from the power. Good. And we also know that u is a function of x. So du over dx will be f prime of x, right? So we'll find du over dx. So dy over du times du over dx will be n u raised to power n minus 1 times, what's du over x? F prime of x, right? So cancel, cancel. So our dy over dx will be the power n. Then u is a function of x. So f of x raised to power n minus 1. Then finally, let me put this guy first. Let me put this guy first. The differentiation of the function. Then we have the function itself, but just that the power will subtract 1 from the power. So this will be the dy dx for chain rule. So this is it. You have y is equals to a certain function of x raised to power n. How do you get dy over dx? Power will come down, which is n, subtract 1 from that power, then differentiate the inside function, which is f prime of x. And that will be all for this video. Please do not forget to like, share, and subscribe to my YouTube channel. Thanks for watching.